I'd like to do a short tutorial on PolyMetriX API. So how to use actually PolyMetriX API. As you know that PolyMetriX is an open source Python library that covers entire machine learning workflow for polymer informatics, starting from curated datasets for clustering temperature, and you have advanced futurization techniques for the polymer, which means you can apply futurization on different parts of the polymer, on sidechain level, on backbone level, and on full polymer level. And you have like custom splitters, like property-based splits and leave and out cluster validation techniques to test the generalization abilities of machine learning models. By installing the PolyMetriX package, you can find detailed instructions in the documentation. The simplest way to install is by using pip command. Copy this pip command. To demonstrate, you can open Google Colab and create a new notebook. I have already created one called PolyMetriX tutorial. Open the terminal in Google Colab and paste the command and hit enter. Once you execute the command, the package will begin installing. All you need to do is wait for the installation to complete. The package is successfully installed. We will now see how to load a curated dataset in PolyMetriX. To keep things simple, I am copying and pasting respective lines of code directly into a notebook cell. Copy this and paste it into a cell. And run this cell to load the dataset. The dataset is stored as a data object, which allows you to access different components of objects such as features, available targets, and metadata. For more details, refer to the API docs. So, and here you can also look some of the things that you can access. You can get like features, and also you can get labels for this dataset object. You can do dataset dot get and features, which this can be as features, and can run this. So this would be the features are stored as an array, and you can also access targets, which can be also, sorry for my typing errors. So the features are stored as an array, and targets are also stored as an array. These features and target arrays can be easily used for training and testing machine learning models. Discuss how to obtain featureizers for polymers using piecewise notation. I am demonstrating an example of full polymer featureization. Import the necessary classes, specifically the polymer class and full polymer featureizer class. PolyMetriX provides various chemical featureizers. To explore chemical and topological featureizers available in PolyMetriX, the API documentation, navigate to the API reference, and then review the featureizers section. So PolyMetriX supports two types of featureizers. One is chemical and topological. Let's go back to Google Colab and run the cell to import required modules. So here we need to define piecewise for the polymer and instantiate the polymer and then specify the chemical featurizers you need to calculate and execute this cell. And the result will be an array. So this polymer has two rings. You can also process like multiple piecemeals with the multi-resist class simultaneously. So create a list of piecemeals. A single piecemeal is shown here, but multiple can be included. Specify the list of chemical featurizers to calculate and execute this cell. So the result will be an array of values for the selected featurizers. So far, we have explored how to obtain featurizers at full polymer level using the PolyMetriX API. Next, we will cover how to extract featurizers at the sidechain and backbone levels. I will not be using Google Colab for the coming parts. Refer the PolyMetriX API documentation, specifically the example notebook, which demonstrates the use of featurizers. Before proceeding, let's clarify the polymer structure. It consists of two parts. The backbone is the main central chain of polymer, and side chains are smaller branches or group of atoms attached to the backbone. And let's go back to raw examples again. To featurize at the sidechain level, import relevant classes such as sidechain featurizer and define the list of piecemeals to identify its structure, and instantiate the polymer object and apply desired chemical or topological featurization to the sidechain. The result will be an again array of features specific to the sidechain. Similarly, to features at backbone level, import appropriate classes for backbone featurizer, and we use the same list of piecemeals and polymer object. So then apply choose an chemical or topological featurizers to the backbone. This approach enables featurization at different levels of polymer, like full polymer level, sidechain level, and the backbone level. Primarily, the PolyMetriX API is designed for polymers, but its modular structure extends to small molecules using a dedicated molecule class. Define list of smiles for small molecules and apply chemical featurizers to extract their features. PolyMetriX API includes a comparator class that quantifies the differences between chemical featurizers of polymers and small molecules. This comparator class enables analysis of interactions in polymer small molecule mixtures using custom comparations such as absolute difference, sign difference, and Euclidean distance. Another key feature of PolyMetriX is that allowing us to add terminal group information for the polymers. So if you know the terminal group information for the polymer, I mean specifically for like sidechain and backbones, you can add those information here and calculate the updated chemical featurizers for backbone and sidechain and also on the full polymer level. And now I will be showing how to train machine learning models using PolyMetriX. Under toy examples, navigate to Train Model Notebook for implementation guidance. Import all the necessary modules, including curated class transition temperature dataset, machine learning models from scikit-learn, and splitters from PolyMetriX. PolyMetriX includes specialized splitters such as TG splitter and polymer class splitter. Import also leave one cluster cross-validation from MoffDescribe. You already know how to load a curated dataset and how to get features and target labels, and define a necessary training and evaluation function. Use this function to train and evaluate models with random k-fold split. Alternatively, apply advanced validation methods such as leave one cluster out validation and also property-based splitter or polymer class splitter for specific use cases. So to recap, the PolyMetriX API supports loading curated datasets, applying featureization at hierarchical levels of polymer, applying featureization for small molecules, analyzing polymer small molecule interactions, adding thermal groups to side chains and backbones for updated featureization, and also training ML models with flexible data splitting options. To understand how PolyMetriX classifies sidechains and backbones, refer to the polymer graphs in the API documentation, which explains graph theory concepts and provides an classification example how it distinguishes between sidechain and backbone. And thus, PolyMetriX API is designed for streamlining entire workflow for polymer informatics. I hope PolyMetriX useful for you. If you run into any issues or have ideas for new features, do not hesitate to reach out by opening a GitHub issue. And thanks for listening and have a good day. Bye.